So welcome back to what I believe now is going to be the 12th episode. Yeah, 12th episode in a series where I'm trying to make high quality PCBs using this very low cost CNC router. So in this episode, we're not going to be making any PCBs. Instead, we're going to be focusing back again on this CNC router and seeing what we can do to make it a bit better. I mean, I've been using it for a while now, and not only did I build it and I've sort of improved it, I've then been using it for a while. So I know what exactly has been causing me troubles and how it actually works, and all of those things you need to know to actually go ahead and then try and improve it. So what I'm looking at to improve in this specific episode, and what probably might span a couple of episodes, is going to be trying to address some of these play issues. For example, we have all of this play here, and in general the play is not too bad. It's mainly in this Z-axis, but there's a little bit of give and take, just enough to make it sort of shift around when we're working in those sub 0.1 millimeters. Additionally, there's quite a lot of flex. I think you could see here, look at that, that's a crazy amount of flex. So that's obviously going to create a lot of movement, especially in that Z and Y axis. And there's a lot of flex in this bed as well. So all of that sort of adds up to little bits of inaccuracies that just doesn't quite give the precision that I'm looking for. Don't get me wrong, it's quite good, and it's good enough to make, as you've seen in the prior videos, some pretty nice boards. But I think I can do a little bit better. The other thing I'll try to do is improve the work area a little bit. I mean, the work area is probably enough for most PCBs that I'm working on, but if I'm going to do it, this Z height here is quite problematic, especially when I have my wasteboard under there. You literally don't have much room to play with because of this layout. So I want to try and lift the Z axis up a little bit if I can. But obviously I don't want to increase the work area too much because it's a bit of a give and take thing. If you start to increase the work area, then you're going to increase the flex, and then you're going to have to increase the rigidity, and so on and so on. So it's a bit of a snowball effect. So just a little bit of an improvement in the size, and hopefully I'll add enough rigidity back in to cope with the improvement in the size, and actually add a little bit more rigidity than I even have now. One of the other things I'm going to look at are these sensors here, which are just typical micro switches. They work all right, but I think they give around about, must be at least a millimeter's worth of difference in the actual homing position every time. And that's probably fine, I guess. But my sensor that I have here for actually auto aligning, you've seen it in the earlier videos, I'll show it on the screen here, that actually requires that the homing be somewhat accurate. And it's not really accurate enough in some cases, and sometimes I have to redo that homing sequence to get everything working. I'm thinking to use optical sensors here for these instead of the micro switches, and yeah, I'm not sure how that's going to work given the dust issues. And in the back of my mind, I'm thinking that maybe if I can get these homing sensors to work accurately enough, maybe I don't need to rely on my homing sensor. One of the other issues that I've sort of noticed when using this CNC is that the processor board, which is based fundamentally on a Arduino Uno processor, it actually seems to be getting a bit hung up in some cases. And I put that down to the fact that if you look at the way that the CNC board is actually burnt, there's a huge amount of very, very tiny moves. So there's not really much time between each of those moves. Whereas in a normal CNC job, you're probably working with things that are a little bit more, have less total moves. It's a simple way to do it. So what I think is happening is that the processor is just getting overloaded in some cases, and then it waits. And waiting is bad, especially when you're burning something, and freezing up is bad as well. So my idea is to see if I can improve the processor here, swap it out for something a little bit faster. And so we'll see how we go with that. And the final thing I want to do is try to improve this spindle. Now this spindle is pretty bad, is the only thing I can put out. I mean, amazingly, it doesn't have that much play in that Z-axis or in any other axis, just sort of moving around in the hand. But it has a bit of run out, probably related to the way it's actually, this ER11 collet is fixed to the spindle here. So anyway, there's not much power here. The run out is bad is what I've noticed. And I suspect over time it's going to be susceptible to Z-axis play. So anyway, getting rid of this is one of my big goals. So what about the money side of things? I mean, this is meant to be a cheap CNC. I mean, that's the whole theme of this series, really, in a way. Well, I think there's a couple of ways to look at the money side of things. First thing is that actually making the CNC, especially going into this next stage, it's more of a hobby related to building and understanding CNCs, as opposed to just keeping the money down. I mean, if you were just keeping the money down, this may not be the most economic way to do what I'm doing. What I'm really trying to do is learn how to make and customize and build this as well, at the same time as achieving the good results on the PCBs themselves. So I think originally, you probably know, these CNCs in their raw form cost around about $100, something like that. And I probably spent a good $150 on the laser and new stepper motors and some other bits and pieces to get it somewhat to this stage. I think that's, you know, these are rough numbers. I mean, and the Japanese yen conversion is changing all the time, and the exchange rate has gone in the toilet this year, so it's pretty hard to sort of give a one-for-one discussion on this. If you're working in American dollars, it's probably a lot cheaper nowadays anyway. So yeah, $100 for the unit, $150 for where we're at now. And then I think I said in the last episode I wanted to spend about $100 to rebuild it. And that's still pretty much where I'm trying to target it. So I want to spend about maybe another $100 on all of the physical hardware to get this up the stage. And beyond that, I'll probably spend about another $60 or $70 just to update Spindle. Yeah, I don't know what that adds up, $400 or $500 US dollars at the end of the day, which sounds like a lot, but I do notice that there are some very high-end routers out there, and they can go for a couple of $1,000s. So I still think it's price-wise quite reasonable, and you know, it's the hobby aspect as well. I'm actually having fun building it, so that's the way it is. So as I said, the next couple of episodes will be me building and rebuilding this. So if you're interested in that, hang around. If you're not interested in that, then you'll have to stand by, because once I finish doing the rebuild on this, we'll be getting back into, yep, that's right, making a bunch of PCBs. And I have a whole heap of projects lined up. It's just crazy how much, every time I get on AliExpress or something like that, or see somebody's video, I buy something else and come up with a new project, but I haven't got any of them really started that much lately. So I think one of the reasons is that I wanted to get this done first and get the PCB manufacturing process really refined to the best I possibly could before seriously trying to get into sort of high levels of production of various boards. So, all right, anyway, that's enough waffle. Let's try and get into getting this done. So there we pretty much have the teardown. There's a bit of cleanup and stuff that I need to do with this, but that's pretty much everything. Yeah, most of these rails and stuff I'll probably replace, but yeah, step by step. Let's get into it and see how we go. All right, so I've laid out everything here so you can check it out. Obviously, I've got the Z-axis here lying down. The big change obviously is going to be the bed length. I've decided to make the bed length longer, and that's primarily because of these materials, these new rod bearings, and the 2040 material that I've purchased is already at this length, and you know, I don't see any need to cut it down for that. Obviously, the bed itself is pretty short in regards to the length of the bed, so at some point I'll want to get a new bed, but for now, you know, I think I'll just build it that way to make it easier. I'm also going to raise the height of the Z-axis, I think I mentioned before, and I'll do that by having some 3D printed insert, which will go in here at some point in the future. You can also see that I've got linear bearings now instead of the those rod style bearings that I had before. So it's going to be a bit of a challenge to figure out how to fit all this onto there, but sort of we'll go there. And I was originally going to put the 2040 material here as well, but I don't have enough of it and I don't want to buy any more. So I've noticed that these linear bearings are actually pretty strong, so I think that's actually going to create some additional rigidity as well. And probably just generally to increase the rigidity overall, what I will do is I'll take the original X-axis pieces of 2040 and I'll chop them up and try to insert them in a few places to try to increase the rigidity, and maybe even on these corners here, see if we can make it a little bit more rigid as well. So back to those rod bearings, you can see that there's also some new fittings, so that should be these are the bearings themselves which will roll on those rods, and they're all metal. And again, it's a bit of a puzzle as how I'm going to mount this onto here, but I guess we'll figure it out. This is the original plastic one, so obviously it's going to be a big upgrade from the plastic ones. And you can also see the rods themselves are far larger. So the rods, I'm not sure if you can see the size difference there. It's a bit difficult to catch, but they're obviously a lot bigger. To mount the rods onto the end plate here, also purchased these little fixtures. Again, they're metal. And I also purchased a new set of lead screws, and they're actually the same sort of specification, but they're obviously longer because I need longer. And obviously the old ones are probably a little bit worn, so maybe I'll get a little bit of a pickup in accuracy with the new lead screws as well. Also purchased these backlash devices for the lead screws. And finally, to sort of make things a bit more rigid again, I wanted to reinforce these. This is actually, it's pretty hard to do on hand. This actually has very little flex, but it has some flex. But I noticed that the screws actually sort of eat into the surface as well. So, possibly washers will improve that. But some of the devices actually, such as the bearings, etc., mount directly on here. So, you're always going to have a bit of pressure there. So what I've done is, what I'm going to do is use these aluminium plates that I've purchased. It's a 2mm sheet, and I will either make a one-sided addition or a two-sided addition sandwich of this material. So effectively that should hopefully improve the strength and rigidity of these pieces as well. So that'll be on the Z-axis as well as this Y-axis. This is probably the worst because this thing's hasn't got much height, so it's probably going to, look at that, it's going to be a bit of a flex there as well. So the idea is to attach that with epoxy. I'm not sure how well it's going to go, but we'll give it a go. So I thought I'd bring you back here for a second to have a look at this that I'm working on, which is just related to the Z-axis. Trying to figure out how much sort of clearance I can get here between the work surface and the bottom of this piece here. So originally it was only a couple of centimeters actually, but in this layout we're getting around about 5 centimeters, and to the original wasteboard surface here around about 7 centimeters, which is quite good. But obviously the tool itself has to be able to reach the surfaces as well. As you can see at this position here to the first wasteboard on the bottom here, basically it's pretty close. I could probably stick it a bit out further. So I think I'm pretty much at the limits here of what I can do. And in effect, you're actually limited by the amount of sort of stick out and the tool that you're going to have in here. So the amount of stick out here, for example, is 5 centimeters, and say 2 centimeters for the tool. So around about 7 centimeters. So yeah, I think that's pretty close to what we're at. So 7 centimeters will be the normal clearance. Now to achieve this, I've actually pushed the mounting surface to be below the surface. You can see it down there. It's actually running inside the surface of the frame. Now originally this was running outside of the surface and would actually travel past the top surface, extending beyond it, and that would still only give you that 18 centimeters of travel. So that means that in the case that I'm using this 40 centimeter length here, this surface here is going to have to now travel inside there. So that means we're only going to get 20 centimeters of travel, even though there's 40 centimeters of length. So it seems like a bit of a waste, but actually I don't mind. I mean, first thing is we're going to get 2 centimeters more, which is nice. And the second thing is that having the working surface only traveling inside the frame itself means that you're not going to have it sticking out and bumping into things. So I think that's the way I'm going to go, and I'll keep going down that track. All right, we seem to be making some good progress here, so I thought I'd show you where we're at. You can see I've actually assembled all of this access here. I guess it's the x-axis. And you can see that I've just put those pieces of the original 2040, which I've cut up in between, to stay between the original 2020 pieces. So that's going to make this whole assembly extremely rigid. It also increases the amount of fixture places that I have, so I can actually fix it to the side of the original uprights here. So instead of having maybe only 2 points, I'll probably go to about 5 points of connection on each side. So that should hopefully make it nice and strong. Obviously you can see I've also put the linear rails on and spent a lot of time sort of adjusting and measuring and making sure it's as perfect as I could get it. And it seems to be running pretty well. You know, as you run it, you can sort of feel some degrees of resistance, but I think that's probably about as good as I'm going to be able to get it. Also, you can see how the offset spaces here are working to mount. So the linear rail is screwed to the 3D printed offset mount, and then obviously I'm screwing that to the Z-axis unit, which is obviously just the base plate at the minute. And on the back here, you can see where the lead screw connection will go, and I've ground down here the bracket that holds the lead screw nut so that it just clears. You can see there it just clears the edge, because obviously this is in the way here. In reality, I didn't want to have this to be so thick, because it sort of increases the amount of lever you have, and I'm sort of trying to do everything to do is to minimize any leverage in the system. But you know, obviously I'm 3D printing it, so having a bit of thickness is going to increase the strength as well. And then we have the issue of this lead screw nut. I'd have to cut a lot more off, and that would weaken that, so I don't think that's a good idea. So anyway, that's what I'm going to try for now. I think it's going to be okay. You can see I've stuck these 2 bolts here on here temporary, so that the linear bearings don't fall out one into the other. It would be a disaster to lose all those bearings. And the next issue that I'm going to be addressing is rebuilding this Z-axis here. And I sort of ran into a little bit of a problem. This is the original Z-axis unit, which sort of screws on, I guess it screws on like that, right? That's probably the top with the stepper motor at the top there. But when I put this on the spindle holder, or whatever you want to call it, the spindle mount block, I found that the bearings that are in here are really weird, right? They're chunky. I don't know if you can hear it, but look at that. Look at that. It just won't move at all. They lock up, and when you spin it, it gets into a really weird position. So I thought, you know, maybe I'm doing something wrong, or maybe I don't understand, but I have the original sort of plastic mount linear bearings from the Y-axis underneath the bed. And if I put them on here, I mean, there's really no play in here, and they spin around fine and move fine. So I'm thinking somehow the ball bearings in here have got a flat edge on them or something weird. In any case, I'm going to have to pull out these bearings somehow, which looks really difficult. Probably do that off camera and replace that. So once I replace that, I think I'll just do the basic rebuild on this Z-axis unit, and hopefully that will be good enough. I'm not really doing much to this unit. Probably just make sure I can get the full throw of the lead screw by actually putting a slightly longer lead screw in. The original lead screw is a little bit too short to get the full stroke of the Z-axis, so that's probably about the only modification I'll do, and obviously fixing these dodgy bearings. So we go to the frame, or the rest of the frame. This is now the much longer bed frame, so long I can get it on the screen there. So originally, as I said before, the bed would actually overhang the frame, but now the bed will ride within the frame here. And you can see that I've added these, and obviously the other side as well, to increase the rigidity of the system. Originally it was just connected with the 2 screws on the end there to the frame mount like that, but now I'll add at least 2 or maybe 3 additional fastener points in here and actually make that much more rigid on that axis. So yeah, And on the uprights, I've already 3D printed a couple of pieces, which I haven't even taken off the is that a skirt or a brim or whatever it's called? Haven't taken it or cleaned it up yet. But in any case, this is basically how it'll go. I will have this here, which I'll sort of pin together and glue together, and then on top of this I'll have one big piece of 2mm aluminium plate, which I will epoxy on top of there. As you can see, I'm going to raise it up by 20mm, so these screw holes here, the original bolts, won't be used, and we'll just be using this line. And you can see that I've added this back section here because the spindle and everything here is applying pressure with lever here, pushing it like this. So I'm thinking that this should create some good back support. I've seen some other people put like big chunks of material on the outside here to try and make this more rigid, and I think that's a good approach too, but I'm sort of trying again to keep it look as normal as possible and not make it as too huge as possible as well. So this is the direction that I'm going with this. On the front side as well, just to again increase the rigidity on this piece as well, I also will be putting an aluminium plate, but I also decided to increase the overall thickness by 1 centimeter. So I have these little 3D printed inserts which will go under. You had to print it in 2 pieces because I can't print that long on my 3D printer. So that's it. So yeah, anyway, next up, let's get on to fixing this Z-axis gantry thingy me jig. All right, guess I'll be showing you bits and pieces as we go. So yeah, I think that's plenty enough for this first episode. We've got those big sort of modules put together, so that's going to help us with the planning. And in the next episode, you can look forward to me expanding those frame panels using that aluminium laminating method. Should be pretty interesting, so I do hope you join me then.